ITAE Medical Research proudly presents a groundbreaking imaging instrument, the microvasculoscope, designed to visualize peripheral microcirculation. Our heart pumps blood through vessels, from large arteries to sub-millimeter capillaries, delivering oxygen and nutrients to billions of cells every second. Now we've developed the microvasculoscope, a cutting-edge tool to explore this intricate microvascular network. Gently place it on the skin to observe microcirculation in real time. You can also capture high-resolution static images with a very high signal-to-noise ratio. For example, images A and C showcase the dorsal nasal artery and facial artery, while B highlights a region at the nose border, HFG on the neck, and D and E on the lips. Larger scale images of the nose border, ear, and fingers are equally groundbreaking. In the center, the microvasculoscope's dynamic transparency feature allows precise overlay of microcirculation imaging onto a standard color image. Many pathologies are linked to impaired microcirculation, including skin cancers. The first two columns display a carcinoma and melanoma in both traditional color and microcirculation views. The altered metabolism of cancer cells drives increased microcirculation activity to nourish the tumor. In contrast, the third column shows a lesion initially suspected to be melanoma or carcinoma. Yet, its microcirculation appears entirely normal, a reassuring sign. Histopathology later confirmed it as a benign blue nevus. Another promising application lies in assessing deep burns. Quantified microcirculation data could guide critical clinical decisions, such as whether skin grafting is needed. Here, we observe epidermization, the skin's regeneration and healing process, tracked with precise, pixel-by-pixel quantitative values from the microvasculoscope. Preclinical studies with mice are also particularly promising. Non-invasive, marker-free, and real-time, the microvasculoscope captures detailed insights. On the right, a standard color image shows the back of a sleeping mouse with a B16 melanoma. On the left, the corresponding microcirculation image reveals the tumor's vascular network with stunning precision. This allows us to monitor tumoral angiogenesis and therapy effects in real time. The microvasculoscope also excels at larger observation scales, even with periodic motions, such as in an ex vivo beating heart. This capability is extremely beneficial for evaluating hearts prior to transplantation. A classical X-ray coronary angiography reveals the heart's deeper structure, while the microvasculoscope image highlights peripheral circulation with remarkable details, trackable in real time. Reproducibility is essential for clinical use. We demonstrate this with a healing scratch on the belly below a nevus, monitored over time by two distinct microvasculoscopes. The microcirculation values align almost perfectly, and the images from both devices reveal identical details, proving exceptional consistency. The microvasculoscope operates on a groundbreaking concept. First, a standard color image is captured, followed immediately by a microcirculation image, enabling efficient overlay. Alongside this high signal-to-noise ratio static imaging, a real-time mode is available. Here's how it works. Incident laser light backscattered by the skin's surface retains its polarization and is filtered out by the optical head. However, photons penetrating deeper layers undergo multiple scattering by moving red blood cells. This creates a depolarized speckle field whose temporal evolution forms our signal. With image depths of up to 3 mm, the microvasculoscope captures a volume microvascular activity index called VMAI, a precise measurable metric of red blood cell movement. This page displays our main publications with the green references directly related to the microvasculoscope. Our groundbreaking images were selected for the front page of the Journal of Biomedical Optics of April 2022. The microvasculoscope doesn't need any marker. It is compact, battery-powered, and portable. It performs real-time microcirculation imaging with reliable and stable metrics. It is eye and skin safe, and you can choose the field of view on request. ITAE Medical Research, Unveiling the Unseen, Transforming Care. This brand new imaging device is now available on www.itae.fr.